Good evening, everyone. I hope my screen is visible and I'm audible. Can someone please respond? Hello?
Yes, ma'am. It's
Okay,
audible and
okay,
visible.
okay, thank you. Please mute yourself. Also, everyone, kindly mute yourself. If you have any questions, you can unmute yourself and ask me. So, I'll start the session now. So, good evening, everyone. Myself, Chaitra Borkar, a PhD scholar from IIT Delhi. And I welcome you all to the first interactive session on the NPTEL online course, Basic Principles and Calculations in Chemical Engineering. The course is instructed by Professor S.K. Majumder from IIT Guwahati. So let's get started. So some general information about these live sessions is that these sessions will be conducted every week on Tuesday from 7 to 9 p.m. The link for these live sessions has been made available to you, and you can access them through my YouTube channel. Uh, the structure of the sessions is such that first we'll go through the overview of the lectures for the corresponding week. This time will go through the lectures of week one, and then followed by a few sample problems, discussing a few sample problems related to your assignment for this week. The lecture one discussed the history of chemical engineering as a profession, which began in 1800s, and how the definition of chemical engineering has evolved over the years. In that now it is basically the use of basic sciences to produce certain commodities which are beneficial to the larger public. Then followed by the contribution of various stalwarts to the field such as Carnot, Clausius, Reynolds, and other great scientists. Then the role of historical events such as the agricultural revolution, industrial revolution, the war situations such as World War One, World War Two, how they really helped in the advancement of this field. So it basically necessitated the wide-scale production of uh, chemicals such as synthetic urea, acetone, synthetic rubber, and these events basically helped in helped in the gaining popularity of the chemical engineering as a field. Uh, Next, the grand challenges for the engineering that are being faced by today were discussed, such as the energy crisis, the pollution crisis, and followed by the role of chemical engineering today, which can be applied to semiconductor production, pollution control, and alternate energy sources, nanotechnology, colloid sciences, and others. Uh, Next was the overview of the chemical processes. The chemical engineering can be divided into is basically a series of either unit processes, a series and combination of unit processes and unit operations. So unit operations here are pertains to physical changes, and unit processes pertain to chemical changes. So, and it implies the commercialization of certain chemical reactions. So, unit processes can be classified based on the process design, or based on the variation with time and space, or based on the phase contact. Unit operations can be either mechanical, electrochemical, or thermochemical. We'll discuss them further. So, unit processes based on the process design can be either batch, continuous, or semi-batch. So what does it mean by batch is that if you have a reactor here, the reactants are input at time is equal to 0, and products are taken out at time is equal to t, or final time. The continuous process implies that the reactants and products keep on flowing. There is a continuous flow of reactants and products through the reactor. And semi-batch can be, there are different options for semi-batch. One can be that one of the reactants is there in the reactor. The other reactant is being added uh, continuously, or it can be that the reactants are there, the product is being taken out continuously. Based on the phase contacts, which can have more than one phases, it can be the two phase. Two phase can be gas, liquid, liquid, solid, solid, gas. Uh, Three phases can be solid, liquid, gas, and four phase can be either oil, there are two immiscible phases such as oil, water, and solid and gas. Based on the time and space variation, it can be the steady state. So the process variable, when they are not changing with time, it is.
Hello.
Hello, yeah.
Actually, your voice is breaking.
Oh, can you hear me now? Am I audible now?
Your voice is breaking continuously.
Uh, is there any problem now? I'm asking you right now. Hello.
Hi, now you are audible.
Okay, okay, okay. Yeah. So, with
Yes,
respect
now
to,
it is good.
okay, okay, you can mute yourself now. Thank you so much. If the process variable do not change with time, it is steady state. If they change with time, it is unsteady state. Um, when the process variables change with time but not with space, it is lumped processes, and when they change with both space and time, it is distributed processes. Next, we discuss unit operations. Uh, Firstly, the mechanical unit operations, they may pertain to either size reduction. So there is a material which is bigger in size, but we want that it should be in a smaller size to be used in the reaction. So we go for size reduction. We can go for separation as well, such that the reactant, suppose there is a metal which is in ore form. How do you extract that metal from the ore? So we can go for separation. This is just an example, one of the example. We Separation also involves either centrifugation, which involves settling, then sedimentation. Um, uh, could you please unmute yourself and ask me, because I cannot see the chat box here. If there's no question, I'll move forward. Then the mechanical unit operation can involve agitation and mixing, such as the homogenization of the solution for a better reaction, and either the transportation of the material. The thermochemical unit operation can involve either the separation or heat treatment. The electrochemical unit operations can be either electrostatic separation based on the electric charges, magnetic separation based on the magnetic properties, and electrodialysis. These are a few examples of thermochemical unit operation. So the first schematic you see here is for distillation. So distillation basically separates two miscible liquids based on their difference in the boiling point. So this is another changes in the physical state using the thermochemical unit operation. So we can use either remove heat or apply heat. So when we apply heat to a liquid, it forms gas. When we remove heat from a gas, it condenses to liquid. We can go for sublimation and freezing and melting as well. This schematic here shows the liquid-liquid extraction. So, here you see that there is some.
So here the this solute may be more soluble in this liquid. That's why the partitioning occurs basically, or it gets the mass transfer occurs from this solvent to this solvent, and then you get this solute in this solvent form, which can be further separated later. This schematic is for absorption
Ma'am,
and yeah, hello, hello. Okay, so this schematic is for absorption and stripping. So this is an absorber where you absorb a gas to a liquid solvent, and here in stripping the mass transfer from liquid to gas phase occurs. So you can take out that absorbed gas from the liquid by increasing the temperature. So reboiler here basically increases the temperature here. This here schematic here shows the heat exchanger. So thermochemical unit operation also involves heat exchange. So whether you want to heat some fluid or remove heat from a fluid, you can do it using heat exchangers. The third lecture involved the discussion of units and dimensions. So the fundamental units, the fundamental dimension and their different system of units were discussed, such as SI unit, AES, CGS, FPS. Next, the homogeneity of dimensions in equation were discussed. So if you know the dimensions of the certain terms in an equation, you can find out whether that equation is valid or not by checking the homogeneity of dimensions. Next, the dimensional analysis was discussed. In that, Rayleigh method and Buckingham Pi method were discussed. So if you have a certain unknown quantity and you want to express it in known dimensions, you can do that using Rayleigh method and Buckingham Pi method. The relation would be empirical, but it will be useful in many ways. And further, the dimensionless numbers given here were discussed, such as Reynolds number, which has the significance of the ratio, giving the ratio of inertial force to the viscous force, Froude number, Euler number, Weber number, Mach number, Prandtl number, Nusselt number, Grashof number, which relates to the free convection phenomena, Nusselt number, which relates to the total heat transfer to the conductive heat transfer, and other numbers. So now we will discuss the 0th assignment. So the first question here was, what is the dimension of velocity? Can anybody give me the answer here? What can be the dimension of velocity?
Option number 3.
Why do you think this is option number 3?
Mt
Velocity.
raised to minus 1.
What is m? According to you, what is m?
Not 3 option, not first option.
Yeah, right. So you may be
First option.
confusing m with meter. No, these are dimension. So dimension will have length, mass, time. Okay. So velocity has units, meter per second, or velocity can be distance over time. So meter per second is the unit. So what will be the dimension? Will be distance upon time, or LT inverse. Correct? So the correct option here is the first option. Is this clear? Anybody has any doubt? Okay, I'll move ahead.
No,
So,
ma'am.
okay, thank you. Which of the following equipment is not used for crystallization? So, according to the lecture given as well, first three are the crystallizers, valid crystallizers. However, this one I've not heard of it also. So, this one is the correct option here. This is not used for crystallization. Crystallization also involves either the evaporative type or vacuum type or cooling type. So these three are valid crystallizers. However, this one is not a valid one. So drying liquid crystallizer. So third question, Grashof number is defined as, you have to choose the correct option from here. So Grashof number, as I told you, it involves in free convection. So basically, if there is a vessel and it has some liquid, if you give it some temperature such that there is a temperature gradient, so this will be T1 and this will be T2. So, and T1 is greater than T2, suppose. So, because of this temperature difference, there will be a difference in density of these liquids as well. So, this will be hotter, this area will be hotter, and this area will be cooler. But because this liquid here is hotter, its density tends to decrease and it will tend to rise up. So this motion created due to, and this cooler liquid will tend to go down. So this motion of fluid created due to difference in temperature is called free convection. So this Grashof number basically gives relates to this motion, a free convection motion. So it will involve buoyancy, because rising up will be buoyancy. There is motion, so there will be some inertia, and because it is a fluid, there will be some viscosity. And as discussed before, here in this slide you can see there is a viscosity square term. So in the denominator it will be viscous force square, buoyancy force into inertia force. So the correct answer here is second option. According to Buckingham Pi theorem, number of groups formed depends on number of variables and number of fundamental dimensions. Number of dimensional group can be formed as, so number of variables is n here. So number of process variables which are there, they are n, and number of fundamental dimensions j, which is usually 3, because fundamental dimension is taken as L, M and T. So what how many groups will be formed is based by the relation between these two terms. So what would be the correct answer here if anybody has gone through the lectures? Can anybody tell me? I'll let you know. The correct relation will be n minus j. So suppose there are 6 process variables, and j is 3. So the number of groups formed will be 3. Fifth question, Reynolds number is equal to, so you have to give the formula for Reynolds number. Can anybody tell me what is the correct answer here?
C.
Yeah, correct.
C
Yeah,
option.
C option. So it is basically the ratio of inertial forces to viscous forces. So for a flow through a tube, you would require its diameter, its velocity, its density, and its viscosity. So this Reynolds number is given by rho ud by mu. U is velocity here and mu is viscosity. So this gives us whether if the Reynolds number is too high, it will be a turbulent flow, or if it is low, then it will be laminar flow. So it basically gives us the flow characteristics. So for a flow in a tube, Reynolds number should be less than 2100. 2100 for laminar flow and greater than 4000 for turbulent flow. Sixth question, diffusivity of gas depends on temperature as, so you have to give me the correct relation or the proportionality relation from here. So diffusivity is basically how freely a molecule or a particle can move from one place to the other. So as you increase the temperature, the molecules of a gas get excited. So they,
DO.
huh? It's all right. So they are more free to move from one place to another. So DAB will be proportional to temperature. However, through a theory called Chapman-Enskog theory, the relation comes out to be, although it is proportional, directly proportional, but the relation comes out to be T raised to power 1.5. So the correct answer here is first. Now, I hope most of the people are familiar with the fixed law of diffusion. So, can anybody give me the correct answer for this? What is the correct relation for fixed law of diffusion? That's all right. So, if you are not familiar with fixed law of diffusion, I'll let you know. This relates to mass transfer. So, if there is some region and suppose some material is in abundance in this area, however it is less in this area, so the mass transfer will occur from higher concentration to lower concentration. And because there is higher concentration over here and lower concentration of here, a gradient of concentration is generated with respect to the length. And this molar flux is proportional to that, and the proportionality constant is diffusivity or diffusion coefficient. However, the mass transfer is occurring from higher concentration to lower concentration, that's why we give it a negative sign. So the correct relation is this, which is given by the second option. Next question. The SI unit of specific enthalpy is, can anybody give me the correct answer for this? All right. So the unit for enthalpy, just enthalpy, not specific enthalpy, is joules. And specific implies any unit by mass. So specific enthalpy will be joule per kg. Okay, so specific gravity of fluid with 28 degree API. So what is degree API firstly? Degree API is American Petroleum Index. So it tells us whether a petroleum product is lighter or heavier than water. So a relation for specific gravity with respect to degree API is given here. So this is the relation. And what is specific gravity is that the density of certain fluid with respect to density of water. So using this relation we can find out the specific gravity. So we are given 28 141.5 by x minus x is our specific gravity or the answer 131.5. So this will be 159.5 and 141.5 by x. So x, if you calculate, comes out to be 0.887. So the correct answer here is 0.887. For a gas liquid mixture, the volume fraction is 0.6, what would be the volume fraction of liquid? So suppose we are given 100 units of some mixture, and in this 0.6 is the fraction of gas. So 0.6 into 100 will be 60. So what will be the remaining one? 100 minus 60, 40. So what will be the fraction of liquid? 0.4. Or you can do just 1 minus 0.6 will give us 0.4, because there are just two components. So two fractions will be there. So if 0.6 is for the gas fraction, what will be the liquid fraction? It will be 0.4. So we'll now discuss, is there any issue? Is the voice still breaking? Okay, so now we'll discuss questions related to assignment 1. So dash is an example of a continuous process. So can anybody give me the correct answer for this? Can anybody give me the correct answer for this? Okay, so the correct answer here, if you look at the different options, so mixing a solution in a pot is basically not a continuous process, it is a batch process. Dairy processing is also an example of a batch process. Fermentation also requires reaction going on over days. So this is also a batch process. However, the production of nitric acid is the continuous process. Next question. So the changes in the process variable with space and time occur in which is the correct answer here? Can anybody give me the answer? Harish, you have a question? You can ask me. Can anybody give me the answer for this? The second question. Alright, so the correct answer here will be the distributed process. The changes in the process variable occur with space and time as well. Um, if you have any issues, you can unmute yourself and tell me. I cannot access the chat box again and again. Okay, next question. The process variables in lumped processes change with time but not with spatial coordinate. Is it true or false? Can anybody give me the answer for this? Right? The process variable in lumped processes change with time but not with spatial coordinates. This is correct. So the correct answer here is true. Select the correct phase contact for absorption process. So as I had told you earlier, in absorption process, the mass transfer occur from gas to liquid. So liquid gas will be available there. and also absorption can take place from in solid liquid phase as well. So the correct answer here is the second option. Next question, match the following. Can anybody give me the correct answers for this? What will be crusher here? Somebody kindly respond. What will be
Size
for crusher
reduction.
here?
C.
Crusher for crusher, what would it be?
Size reduction.
Yes, correct. So crusher such as jaw crusher is used for size reduction. So A will be 4. Um, for vibrating screen, what would it be?
Size separation.
Yes, correct. Vibrating screens are used to separate larger particle from the smaller
Size separation.
particles. Yeah, correct. Size separation. So from larger, if there's a mixture of particles which have different sizes, you can use vibrating screen for size separation. What will be for pump?
Transportation
Transportation
of
of
material.
materials.
Yes. And lastly, rotating homogenizer is used for agitation and mixing. So the correct will be A4, B1, C2, and D3. So option C. Flotation is an example of. Can you give me the answer for this as well?
Separation.
Yes, separation. So froth flotation is used to separate metals from their ores. So it is a separation process, mechanical separation process. Next, convection, which is a heat transfer process, involves. What will be the correct answer here?
Energy transfer by fluid motion.
Yes, correct. Second option. So, as I have already discussed with you, free convection, it is basically energy transfer by fluid motion. Now, next question. Select a process which is a mechanical separation process which applies a force that acts away from the center to separate components of a mixture according to their density and or particle size. So, what will be the correct answer here? Can anybody give me the answer for this?
Centrifugation.
Yes. So basically, centrifugal force is applied which acts away from the center. Centrifugation. Next question. In distillation, the mass transfer occurs from. What will be the correct answer here? Can anybody give me the answer for this?
Liquid to gas.
Yes, correct. So distillation. Suppose this is a distillation column, and this is a some mixture coming in with X and Y. So X is coming out from the top and Y is coming out from the bottom. So these are two liquid components in this mixture, and one component is coming out from the top and another is coming out from the bottom. So there is some condenser here and some reboiler here. So in this there are different, this is a plate type distillation column I'm showing here. So the liquid mass transfer from liquid phase occurs to the gaseous phase. So the gases
But I think
rise.
distillation happened to liquid phase to gas phase and gas to again liquid phase.
Yeah. But here the option I've given is liquid to gas, so the correct option here will be liquid to gas. Okay. SI unit of energy. This is quite an easy one. Can anybody give me the answer? SI unit of energy?
Joule.
Yes, correct. What can you write joule as in another SI unit? Joule will be,
Electron volt.
yeah, electron volt is correct. Newton meter. I'm asking for other SI units. Newton is SI unit for force, meter is for distance. Next question, which of the following is a dimensional analysis method? So as we have uh, seen before, the Rayleigh's method is the correct answer here. Which of these is not a fundamental quantity? What is the correct answer here?
Energy.
Yes, because length, mass, and energy can be expressed in terms of length, mass, and time. So if energy is Newton meter and Newton is mass into acceleration, so dimensions of Newton is ml t minus 2, mass, acceleration, and one more length. So the dimension is ml2 t minus 2. It can be expressed in terms of mass, length, and time. What are the dimensions of pressure? Can anybody give me the answer here? Just a minute. Yeah. What will be the correct answer here? The correct answer here will be, let's get to that answer. So, pressure is per unit area. So, in the last slide, I had discussed that force is, the dimension of force is ml t minus 2. And for area, it will be length square. So, the correct answer here will be ml minus 1 t minus 2. What is the unit of pressure? Can anybody give me the answer for that? SI unit of pressure.
Pascal.
Yes, correct. Weber number, a dimensionless number, is a ratio of. We have discussed this before. Can anybody tell me what is the correct answer here? Okay,
Inertia
all right.
force and viscous force.
Inertia and viscous is Reynolds number. The correct answer here is inertia force and surface tension force. So it relates the ratio of inertia force and surface tension force. Weber number. Next question. A low value of Euler number means that dash are large in comparison with dash. Can anybody tell me what is Euler number? What is it is the ratio of which two forces? I'll let you know. Pressure forces and inertial forces. So if Euler number is low, so the denominator must be high and numerator must be low. So inertial forces are large in comparison to pressure forces. So the correct answer here is B. Kindly unmute yourself and let me know. I cannot access the chat box again and again. Sorry. Next question. For laminar flow in a tube, the Reynolds number should be. What would be the correct answer here? I have discussed this.
Less than 2100.
Yeah, correct. So for a laminar flow in tube, the Reynolds number should be less than 2100. Which of the following is not a dimension? What is the correct answer here?
Mass.
Not a dimension. Mass is a dimension, right? We write ml t minus 2. So kg
Current.
meter per second square. What? Can you repeat?
Current.
Hello? Current is also a dimension. Current is another dimension.
Kelvin.
Yeah, correct. Kelvin is unit of temperature.
Kelvin.
Temperature is the dimension. Temperature is the dimension whose unit is Kelvin. Next question, which is the last question. Select advantages of using dimensionless groups. So dimensionless groups can be used for scaling of process, simplifying complex phenomena as we have seen in the lecture given by Professor S.K. Majumdar, and non-dimensionalization of an equation. If you don't want any dimensions or units in an equation, you can use these dimensionless groups. So all of the above is the correct answer here. Any questions, anybody? Get the link of this recording session. Any other questions? PPTs will also be shared with you. Yeah.
I'm actually the assignment date, is the date, there's a confusion, like, you do have to submit the week one assignment on 5th Feb, or it is 2nd May.
5th Feb.
Okay, thank you, ma'am.
Yeah. Any other questions related to the material that I've shared today? Anything you didn't understand from the slides? Anything? There is already a discussion group for this course. You can join that discussion group and post your questions there. There is a Google group for this. If the link, I can share you in the next session, or the emails may have been shared with you for the discussion group as well. I don't have the link readily available with me right now. I can share it with you in the next session if you want. If there are no further questions, uh, I'll consider to close this session now. Thank you so much, everyone, for joining. And if you have any questions, you can post it on the discussion group. And if you have any questions regarding the assignment one, we can discuss it in the next week. Thank you so much for joining, everybody.